Hello, hello. Let us solve some numerical based on this RLC circuits. Let us consider that a resistance of 50 ohm and 50 microfarad capacitors are connected in series across a 230 volt 50 hertz supply. Find current in circuit, voltage across resistance, voltage across capacitor, power factor, active, reactive, and apparent power. So what is given the data? Given data is resistance is of 50 ohm, capacitance is of 50 microfarad. As this is a capacitance given in microfarad, let us convert this capacitance into equivalent reactance. So equivalent capacitive reactance Xc is equal to 1 upon 2 pi Fc. So it is equal to 1 upon 2 pi 50 into capacitance is 15 to 10 raised to minus 6, that is 50 microfarad. So it gives you 63.66 ohm. So we know that impedance Z is equal to what? In case of RC circuit is R minus JXC. So impedance Z is equal to R minus JXC, that is 50 minus J 63.66. So if I convert this rectangular quantity into the polar, if I converted rectangular quantity into the polar, it will become 80.95 at an angle of minus 51.85. 81.95 at an angle 51 minus 85 ohm. Impedance is measured in terms of ohm. So I will calculate the current. The applied voltage is what? 230 volts. So let it applied voltage is taken as a reference. So 230 at an angle of 0 divided by Z, that is impedance. So I is equal to V upon Z. So 230 at an angle of 0 divided by 80 minus 95 at an angle of minus 51.85. So this will give you the current 2.84 at an angle of 51.85. It indicates that voltage is taken as a reference. So 0, current is leading by 51.85 degree. I will calculate the voltage across resistors. Voltage across resistance VR is equal to I into R. So I is equal to 2.84 into 51.85 degree into 50. So it will give you 142 at an angle of 51.85. That is VR, and I angle is same, but the magnitude is different. So VR is in phase with the I. So it is value is 142 point at an angle of 51.85. What you can say, volt. So sorry, here unit is not ohm, it is unit is ampere, and here unit is volt. Okay, so let us calculate the voltage across capacitance. Voltage across capacitance is equal to I into minus JXC. So I into minus is 2.84 into 51.85 minus J 63.66 is, if I multiply these two terms, so it will give me 180.8 at an angle of minus 38.6 degree volts. If we see the angle difference between this voltage and this voltage is exactly 90 degree, we will get the angle difference between I and VC is 90 degree. I will calculate the power factor. Power factor cos phi is equal to R by Z. So R is 50 divided by Z is 80 point, magnitude of Z is what? 80.95. So 50 divided by 80.95, 0.618. But whether it is a lead or lag, as the circuit is RC, the power factor is always leading. So it is leading 6.618 lead. So you can calculate the power factor using that cos of angle of voltage minus angle of current. Angle of voltage is what? 0. Angle of current is what? 51.85. So minus 51.85, cos of minus 51.85 is 0.618 lead. So power factor is this value. I will calculate the active power. Active power is calculated as P is equal to VI cos phi, 230 into 2.84 into power factor cos phi 0.618. So it gives you 403 watt. Similarly, P is taken also can be I square R. So P is equal to I square R. If we tally that, this both answers is almost similar. So 403 watt. Okay. Reactive power Q is equal to VI sin phi, that is 230 into to 2.84. Phi value is what? Minus 51.84. Sine of minus 51.85. So it will give you 513 VAR. Q, reactive power, is measured in terms of VAR. Similarly, Q is equal to I square XC. So it is 2.84 square into XC, that is 63.66. So it is give you minus 513. Why I am taking this is power as a minus? So sorry, here also the sign is required minus. Why I am taking this sign as a minus? Because minus indicates that the reactive power is supplied in, and capacitance always supplies the reactive power. I will calculate the apparent power. Apparent power is equal to S is equal to V into I. It's 230 into 2.84. So it gives you 653.2 VA. So 650, this also can be calculated as S is equal to P plus JQ, or S is equal to under root P square plus Q square. So using this also we can calculate that is 653 VA. So this way we can solve the problem. Okay, similarly you can try the problem of what? RL circuit. So in this, what resistance of 50 ohm, what I'm changing, instead of capacitance I'm connecting the 100 millihenry inductance. So 100 millihenry inductance and resistance of 50 ohm is connected in series across a 230 volt 50 hertz supply. Find the current, voltage across resistance, voltage across inductor, power factor, active, reactive and apparent power. So R is 50 ohm, L is equal to 100 millihenry. So what will be the value of XL? XL is equal to 2 pi FL. So substituting the value of F and L, F is 50 hertz, so 2 pi 50 into 100 millihenry 100, so it will give 31.42. And impedance Z is equal to what? R plus JXL. Impedance Z is equal to what? R plus JXL, that is 50 plus J, 31.42, that is 59.05 at an angle of 32.15. So this is the impedance. How will you calculate the current? Current is equal to I is equal to V upon Z. So using this formula I can calculate the current. Sorry, this unit is must be ampere, it should not be ohm here, it is ampere. So it gives you 3.85 at an angle of minus 32.15 ampere. How you calculate the voltage across resistance? Voltage across resistance, VR is equal to I into R. So current is calculated over here, multiplied the resistance with 50 ohm, so it gives you VR. How will you calculate the voltage across capacitance? Sorry, here it should not be voltage across capacitance because we are taking the example of inductance, so it should be voltage across inductance. Voltage across inductance, that is VL, is equal to I into JXL. So it should be VL I into JXL. If I calculate this VL, it will give you 122.38 at an angle of 57.85 degree. How we calculate the power factor? Power factor is equal to R by Z. That's 50 divided by 50, Z is 59.05, 59.0, so 0.845, or you can take the angle of voltage minus angle of current, it is 0 minus angle of current is minus 32.15. It indicates what angle? This angle indicates that the current is lagging to the voltage by minus 32 degree. Okay, so it is 0.847 lag. Okay, how will you calculate active, reactive and apparent power? So active power is equal to VI cos phi, that is 230 into 3.895 into power factor, so this will give you 758 watt. P is equal to I square R. Similar way we can calculate reactive power Q is equal to VI sin phi. So here phi is the plus, so that the reactive power is also plus because it is what supplied by the, it is supplied. क्या कर रहे हैं? This is what supplying the absorbing the reactive power. As it is absorbing the reactive power, it is taken as a plus side. Q is equal to I square XC. By using this formula you can calculate, or apparent power S is equal to VI. Using this we can calculate the VI. This is just like a similar example, only what the capacitance is changed to the inductance. Okay, that is the only change you can see here. Okay, take the next example. A coil of 15 millihenry is connected in series with the 25 ohm resistance. Okay, the coil is having the inductance of 50 millihenry in series with the capacitance of 25 ohm and a capacitor across 230. So capacitor's value is not given. 230 volt 50 hertz supply. Find the value of capacitor so that the current draw is maximum. We have to find out the value of capacitor such that when the current draw the circuit is the maximum. What will be the power factor and power consumed? So resistance is given as 25 ohm. XL is equal to 2 pi FL. So using this 15 millihenry, so 2 pi 15 to 15 into 10 raised to minus 3, we can calculate the XL. So in RLC circuit, when the current will be maximum? In RLC circuit, the current draw is the maximum whenever there is a resonance. So that the current carried by RLC circuit is maximum when resonance is occur at F is equal to 50 hertz. Okay, so F0 is equal to 1 upon 2 pi under root LC. So using this formula, I will calculate the omega 0. 2 pi is multiplied with 0, so omega 0 is equal to 1 upon under root LC. So omega 0 is equal to 2 pi into 50, 1 divided by L is equal to 15 millihenry. This is 15 into 10 raised to minus 3 C, taking the square of both sides and calculated the value of the C from this equation. So C is what? 675.47 into 10 raised to minus 6 farad, that is 675.47 microfarad. Okay, so at the resonance, what? R is equal to Z, hence power factor is what? Cos phi is R by Z. So R is equal to Z, so cos phi is also unity. The circuit becomes pure resistive. Now how will you calculate the current? Current is equal to I is equal to V upon Z. It is 230 divided by 25. So because Z is equal to R, so 230 divided by 25, the current is 9.2 ampere. How will you calculate the active power? It is VI cos phi. So V is 230, I is 9.2, cos phi is the unity. So it will become 2116 watt is the power consumed by the circuit. Let us have a next example. Here two impedances are connected, Z1 and Z2 are connected in parallel, and impedance Z3 is connected in series across the combination of Z1 and Z2. So Z1, Z2, Z3 values are given and they are connected, Z1, Z2 are connected in parallel, whereas Z3 is connected in series. Voltage applied across this is 200 volt, 50 hertz. Calculate current flowing through Z1, Z2, Z3. We have to calculate the current flowing through Z1, Z2, Z3 and voltage across each element, that is V1 and V2. That's voltage across this parallel combination, and V2, that's we will to calculate. So V is given as the 200 volt, Z1 is 7 plus J5, Z2 is 12 plus J8. Sorry, here the plus sign is missing. Z2 is equal to what? 12 plus J8, and Z3 is equal to 8 plus J10. 8 plus J10. These values are given. So this is what? 200 volt. So Z is equal to Z1, Z2 divided by Z1 plus Z2. How will calculate equivalent impedance? These two are in parallel. So Z1, Z2 divided by Z1 plus Z2 is the equivalent of this. So Z1, Z2 divided by Z1 plus Z2 plus this series impedance, that is Z3. So substituting the values of Z1, Z2 and Z1 plus Z2, substituting all these values. Okay, so this values was 12 minus J8. So 12 minus J8. So here minus sign is also doubles. It should be minus J8, 8 plus J10. So it will give you the 14.335 plus J11.211. So sorry, here only one minus sign is required. Keep in mind while solving this is 12 minus J8. It is not 12 minus J8. It is 12 minus J8. Okay, so total current through the Z3 is equal to I is equal to V upon Z. So it is 200 divided by total impedance Z. This is the value of the current. Okay, this is the value of the current, what? I3, that is current, total current, current through the Z3 is nothing but I3, which is nothing but a total current. Total current I is equal to what? V upon Z. So 200 at an angle of 0 divided by 14 impedance, which is calculated, it is gives you 11 at an angle of minus 38.02 ampere. Similarly, current through the Z1, I will calculate the current through the Z1. The current through the Z1 can be calculated as, I want to current through the Z1. So in parallel combination, we can use the current distribution law. If I want to calculate the current through Z1, take the opposite resistance in the numerator. So Z1 current is to be calculated, hence Z2 is taken as in the numerator. So Z2 divided by Z1 plus Z2 into I. So Z2 is substituted, Z1 plus Z2 is substituted. Sorry, here again 12 minus J8, here again 12 minus J8 is not minus minus. 12 minus J8, 12 minus J8. So this will give you the current I1. Similarly, I will calculate I2. I2 is equal to, if I want to calculate I2, so I will take Z1 in the numerator. So Z1 divided by Z1 plus Z2 into total current I. That is the total current summation of this current I. So I2 is calculated. How I calculate the voltage drop across these two parallel combination? First, I have to calculate the parallel impedance. So Z1, Z2 divided by Z1 plus Z2 is the equivalent impedance into current flowing through this much is what? This parallel combination is I1 plus I2, that is total current I. So V1, voltage drop across Z1 and Z2 is V1. So V1 can be calculated as Z1 Z2 divided by Z1 plus Z2 into I. So this will be the give the value of V1. Similarly, voltage across Z3 is equal to, so voltage across Z3 is equal to Vt, that is current flowing through this I3 or I is equal to Z3 into I3 or I. So that it will give the voltage drop across the voltage across these combinations. Okay, thank you. Okay, similarly next problem, what is given? Similarly next problem, it is given as the current voltage is 200 volt and there are two branches ZA and ZB in parallel. ZA draws the 8 ampere current with 0.85 power factor lagging. ZA is not given. The current IA is given as 8 ampere with 0.85 power factor lagging, and the total current I, this total current I is a 7 ampere with unity factor. So I is equal to 7 ampere at unity power factor. So IA is 8 at an angle of, it is lagging, hence taking as a minus cos inverse of 0.8, that is 8 at an angle of minus 31.79 is this current which is carried by the ZA. Similarly, I is 7 at an angle of cos inverse of 1. Cos inverse of 1 is 0, so 7 at an angle of 0. So total current I is equal to IA plus IB. From this I can determine I and IA is known. IB is equal to I minus IA. Determine this. I will calculate the impedance. Impedance I know the voltage, total voltage is V. So V divided by I is nothing but ZA. So V divided by IA is nothing but ZA. Similarly, ZB is equal to V divided by IB is ZB. So from this we can calculate ZA and ZB, and I want admittances. So admittance is Y is equal to 1 upon ZA and YB is equal to 1 upon ZB. Take the complex calculation on the calculator. So by this way you can solve this problem. You can try this problem in the home. Thank you.